Every time you send a request, a login, a search, an API call, you're writing a message on the wire. And if someone is watching that wire, they can read everything you didn't think to protect. Wireshark is a free, open-source packet analyzer used by network engineers, penetration testers, and security researchers worldwide. It lets you capture and inspect every packet flowing through a network interface in real time. Before we go any further, an important disclaimer: capturing network traffic is only legal and ethical on networks and systems you own, or where you have explicit written authorization to test. This means your own home lab, a virtual machine setup, or a bug bounty programs in scope assets where packet capture is explicitly permitted. Unauthorized interception of network traffic is a crime in most jurisdictions. Everything in this tutorial is intended for authorized, ethical security research only. When you first open Wireshark, you're presented with the capture interface list. These are all the network interfaces on your machine, your Ethernet adapter, your Wi-Fi card, any virtual interfaces from VMs or VPNs. You'll see a live graph showing which interfaces have active traffic. Below the interface list is where the real action happens. Once you start a capture, the packet list pane at the top shows every packet in real time. Source, destination, protocol, and a summary. Click any packet and the packet detail pane expands the full protocol stack. Ethernet frame, IP header, TCP segment, and the application layer data. At the bottom, the packet bytes pane shows the raw hex and ASCII representation of every byte. To start a capture, double-click any interface, or select it and click the blue shark fin button. Wireshark immediately begins recording every packet it sees. To stop, click the red square stop button. You can save the capture as a PCAP file to analyze later, or share with your team. Display filters are where Wireshark becomes a precision instrument. In the filter bar at the top, type HTTP and press enter. You'll see only HTTP traffic. Type tcp.port == 443 to isolate TLS encrypted web traffic. Use DNS to watch name resolution requests and responses. Filter by host with ip.addr == followed by an IP address to focus on one machine. Combine filters with $ampersand. For example, http ip.addr == 192.168.1.100 shows only HTTP traffic to or from. That host filters are case sensitive and support comparison operators. Logical in, OR, and not. Mastering filters is the difference between drowning in noise and seeing exactly what you need. Once you've captured traffic, following a stream reconstructs the full conversation. Right-click any TCP packet, go to follow, then TCP stream. Wireshark reassembles the entire back and forth exchange and presents it as readable text. Red for client data, blue for server responses. For HTTP, you'll see the raw request headers, cookies, query parameters, and the full response body. This is exactly how an attacker on the same network segment would see your unencrypted traffic. In a controlled lab environment, using a purposefully vulnerable application like BBWA or your own test server, you can observe exactly what data travels in the clear. Credentials submitted over plain HTTP appear as readable text in the stream. Session tokens passed in URL parameters are fully visible. Custom API headers, authentication bearer tokens, and sensitive form fields, all exposed. This is why HTTPS, HSTS, and secure cookie flags matter. When you're doing bug bounty work on an authorized scope, look for mixed content requests, legacy HTTP endpoints, and token leakage and redirects. These are real findings. Wireshark is a powerful tool, and with that power comes responsibility. Only use it on networks and systems you're authorized to test on bug bounty programs. Verify that your rules of engagement permit active packet capture. Many programs scope to web application testing only. When you find a real vulnerability through authorized research, report it through the program's coordinated disclosure channel. Give the vendor time to patch before going public. The security community advances when researchers act with integrity. Stay curious, stay authorized, and happy hunting.